Okay, section 7.2 is going to be split into two parts. The second part is going to start with the slide entitled Definitions, where it starts talking about the definition of ready tasks. Alright, so we can have this priority list, which means that it's a list of the task in order from the highest priority to the lowest priority. What we think is most important to be done first, second, third, so on and so forth. How we think that they should be done. Now, your priority list, just because you think something takes top priority, your precedence relationships are going to override your priority list whenever you have a precedence relationship. So what that means is, if you think it's more important to get your shoes on than your socks on, you still have to put on your socks before your shoes. So in this example, we have a woodworking project with 7 tasks. And here's the diagram to represent that. What we want to do is determine the critical time. Now this goes back to what we did in section 7.1. What you're going to do is you're going to find your maximal path, find each of your maximal paths, determine their times. Whatever the largest one is the critical time. So, determining the critical time, we have T1, T2, T5, T7. Then T1, T4, T7, T1, oops, I skipped something, T3, T1, T3, T4, T7, T1, T3, T6, T7. Alright, 3 maximal paths. Start at sources, end at sinks. So 5 plus 15 plus 10 plus 30. This one is 60. 5 plus 20 plus 35 plus a 30 is 90. 5 plus 20 plus 25 plus 30 is 80. So those are our 3 maximal paths. This is our critical path, and this is our critical time, which is the shortest possible completion time. So now we're going to create a priority list that goes from the shortest completion time to the longest completion time. Well, the shortest completion time is 5, and it's in minutes, so 5 minutes. So T1 comes first. Next completion time is T5 with 10 minutes. Then 15 minutes is T2. 20 minutes is T3. 25 minutes is T6. 30 minutes is T7. And the last one is T4. So that is a priority list based on completion times from the shortest to the longest. So that is called an increasing time priority list. The time that it takes you to complete a task is increasing, so it's an increasing priority list. If we do just the opposite and start with the longest and work our way down to the shortest, that would be a decreasing time priority list. So we're asking, how would one processor finish a job if we have this woodworking example and we have the increasing time priority list? Well, we look at our priority list. T1 is what we want to be done first. Well, that's okay. We can do T1 first. Then it says we need to do T5. Well, T1 is done. And it says we need to do T5. Well, T5 can't be done before T2. So we can't do T5 yet. So we look and the next thing on the priority list is T2. Well, the only thing that comes before T2 has been finished, so T2, we can do that now. Now you always want to go back to the beginning of the priority list. T5, well, T2 has been finished, so T5 can be scheduled. Next on the list is T3. Everything that comes before T3 has been scheduled. Then T6. Everything that needs to come before T6 has been scheduled. T7, we still have one thing that has to come before T7, and that's T4, and then T7. So that's how one processor would handle with a priority list, increasing time priority list. Gantt charts, what we have with Gantt charts is we have boxes that represent the task, and then we have numbers, and it's just a continuation of the number line. So T2, and this is exactly what we just wrote a minute ago, T2 goes from 5 to 20, which is 15 minutes. But notice we say 5 plus 15 gives us the 20. So it keeps adding up to the very end, which tells us our completion time was 140 minutes. Okay, this is where we'll pick up next time.